Hi guys, today I'll be discussing some basic concepts on solids and fluids. So as we recall the physics which we learned in our higher secondary or high school, so we know that a substance exists in three primary phases, as you can see in the picture: solid, liquid, and gas. Okay, and in some cases at very high temperature, there is a phase called plasma as well. Okay. So just let's limit ourselves to solid and fluid. Okay. So what is fluid? A substance in the liquid or gas phase is referred to as fluid. Okay. So this particular, for instance, water and water vapor, we can put into the classification of fluid. Okay. So solid example is ice, whereas fluid the example is water and water vapor. Fine. So, how do we distinguish, for in a general sense, how do we distinguish between solid and fluid? So, as we know that, let me just use my pen. So, as we all know, uh, consider there is an ice cube or any solid. So, it's kept on the ground, and we are applying a force. Okay, a shear force. Shear force which is causing a change of shape of that particular solid. Okay, so a particular um, shear happens. Okay, in the direction of the force, the material or this particular solid shears. Okay, so here you can see a particular limited amount of shear which is being subjected to this solid. I'm just denoting it as S. But what do you think? I mean, if there is this liquid over here, it's over here, okay, it's on top of this substance. We are applying shear force. What do you expect? Will this particular substance shear just like solid, or will it be exhibiting the same characteristics when it is experiencing shear force? So as you guessed, it won't. Okay, because this solid was subjected to shear force, and it what do you call exhibited a limited amount of shear. Why? Because it could resist the shear. So what happened is, when we apply a shear force, this particular solid, this material is trying to resist it, and thereby it is deforming. Okay. Whereas when you apply a shear force to solid, this shear force is deforming this fluid layer continuously. Okay, the fluid resist, does not resist shear. Okay, so what happens is, no matter how small this force be, the fluid continuously deforms rather than a particular limited amount of shear exhibited by solid. And one more thing is, as you may know, for solids, we know that this shear stress, tau, that is equal to F by A, where F is the shear force and A is the area upon which the shear force is applied. Fine. So this tau is proportional to shear strain. Hmm? Okay, I'm denoting shear strain as gamma. We may denote it in epsilon xy, as up to you. So, and I'm saying this shear strain, hmm, gamma. Fine. So this is the relationship for a solid, the relationship between shear stress and shear strain. But for fluid, okay, for fluid, the shear strain is proportional to the strain rate. Okay, d gamma by dt. Hmm? So we discussed the shear strain and shear strain rate. Okay, so tau is proportional to gamma, For solid, tau is proportional to d gamma by dt. For fluid, these are the basics. Okay. So what else do we consider as differences between solid and fluid? One main difference is um, the interaction within the molecules of solid and fluid. So the solid, the molecules are experiencing high coercive forces. So that's why solid is compact. As you may see in the eyes, the solid is very compact. So the molecules are ordered and ordered molecules, molecular arrangement we can call. Okay, and intramolecular bonds are very strong. Thereby, the coercive forces between the molecules are high. That's why the molecules within solid are closely packed. As I said, compact. What about liquid? They are less ordered. However, the molecular forces, the intramolecular forces, are higher than that of gas. And when it comes to gas, there is no order arrangement. It is random. The gas molecules move randomly here and there, and the energy interactions or the interactions between molecules occur due to the collision of the gas molecules. Okay, so that is when it comes to the gas. Okay, so that is one major difference between solid, liquid, gas at the molecular level. Fine. And one more thing I would like to discuss is the last one, that is called free surface. That I will distinguish between liquid and gas. So we know we say we call them as fluid as a single group, but the liquid has got a free surface. As you may see, if you just pour water into a beaker or a container, you may see a layer like this, right, at top. Fine. So this particular layer is the free surface. But do you expect to have such a layer when it comes to gas? If you're filling gas, the gas molecules are random. Okay, there is no such free surface. This free surface is due to the intramolecular forces as well. You get it? And the gas molecules, they randomly move and they just expand and go out of this particular volume. But whereas liquid molecules, they remain in this volume or this particular beaker, and there we can have a free surface over there. I hope that is clear to you. Have a nice day.